All right, everyone, let's get the show started. Welcome to our DevOps office hours. It's September 1st, 2021. My name's Eric Osterman, and I'll be leading the conversation. I'm the founder and CEO of Cloud Posse. We're a DevOps accelerator, and that means that we help companies own their infrastructure in record time by building it together with your team and showing them the ropes. So if that sounds interesting, head over to cloudposse.com/quiz to get started. Again, that's cloudposse.com/quiz to get started. For those of you new to the call, the format is very informal. My goal is to get your questions answered, so feel free to unmute yourself at any time if you want to jump in and participate. If you're tuning in from our podcast or YouTube channel, you can register for these live and interactive sessions by going to cloudposse.com/quiz, cloudposse.com/office hours. Again, that's cloudposse.com/office hours to register and get an invite for these weekly calls. We host these calls every week. Our call today is recorded. We'll automatically post a recording of this to our YouTube channel. So if you enjoy the content and want to support it, please hit those like and subscribe buttons. It helps us out a great deal. So with that said, let's kick this off. I got a number of announcements this week. One is a pretty significant one. If you are using our EKS Node Group module, this affects you. And basically what we did is we rolled up about 12 different fixes or issues that had piled up in addition to making one other breaking change. Basically, we wanted to reduce the number of breaking changes. We have an unfortunate thing that we are having to grapple with is the biggest value proposition working with Cloud Posse modules is a standardization of the interface and ensuring that our modules interoperate with each other very well as that increases the stability overall of the ecosystem. Well, one of the problems we've had was how we handle security groups was not standardized. And we made a first attempt at this, and we started rolling out our security group module. Forget exactly where it's referenced in this code, but the realization was the way we had implemented it introduced the kind of like count of cannot be computed kind of problems in Terraform, which we had famously in 0.11. Well, Jeremy on our team has worked through these and these edge cases, and I think it identified all the problems, but it led to breaking changes in the module. So one of the things we've resolved to do, at least for these kinds of things, is better communicate those breaking changes. So we're keeping something like a change log, but a migration log of the steps that you need to perform to migrate between these versions. As you know, we are still running on using the semver 0.x escape hatch, which says that any release can be breaking, and it is because of this kind of maturity issue that we're still trying to get through the last of these issues. After we finish rolling out the security group module changes to our module ecosystem, we're pretty close to getting to 1.0. I think the last thing we're going to revisit is how we handle IAM consistently for all of our modules to make it very easy to override the default policies that we define in the modules. Again, that hasn't been decided yet, but that would be one of those kinds of things. So yeah, for the full list of improvements, we refer to that in the migration log as well as to why some of these have happened. One thing I do want to point out is a really nice little escape hatch. If you want automatic encryption in transit in AWS, there's a little known secret for how to get that automatically without installing any service mesh. And you can use a subset of the Nitro instances that offer automatic transit encryption. And that way, if you're operating in a VPC, all inter EC2 traffic will be automatically encrypted. Now, not encrypted over a transit gateway, but within the VPC and within those Nitro instances, they will be encrypted. All right. Any questions, concerns about that one before I move on? All right. Another announcement. So we're big fans of GitHub Actions, but there are, until recently, there were 3 really major issues, I think, limiting their utility in the way that Cloud Posse does reusable infrastructure. So, you know, our big claim to fame at Cloud Posse, right, is having this massive module ecosystem. It allows us to come into a new engagement with tons and tons of pre-existing materials that we can use and roll out a consistent platform rapidly and stably. Well, GitHub Actions has the potential for being that for CICD, but for the longest time, the implementation of GitHub Composite Actions was crippled. In fact, their documentation still refers to how they are crippled. So originally, Composite Actions seemed like the holy grail for basically creating a Terraform module equivalent for GitHub Actions, right? Build all your business logic into a workflow, use all the third-party actions you wanted, and then parameterize it and call it from other repos with a very simple action step. Well, the problem was it used to only support shell steps. And a GitHub workflow that only does shell steps and doesn't leverage a single third-party action is pretty useless in my book. So we never were able to use it. Well, in the past week, last week, they released the ability finally to have these robust composite actions. So now you can call any action, you can parameterize your workflow with inputs, and then now you can just simply call your powerful action with those parameterized inputs. So you can dry your pipelines up radically in your organization. And there's still one big downside, is that GitHub Actions don't support private actions. So this action that you create for your company would still need to be public. So make sure you parameterize the heck out of it so it doesn't disclose anything that you don't want disclosed. Any questions on this or observations?
Well, may I ask a question?
Yes, Dennis.
Hello, hello, Eric. First of all, thanks for this, for your
sure.
patience. And my question is, well, this is maybe simplifies some steps which can be combined. But what about reusing the whole workflows?
Well, so this is reusing the whole workflow. So you package up your whole workflow in one action, parameterize it, and now from other repos you can call that entire workflow with one action step.
But in this case, I will have only one job. It's like because that composite action I cannot split into multiple jobs.
Well, so I don't know the degree to which the workflow can be parameterized, and if it's only on steps here. So it looks like, yes. So you would probably in this case create 2 composite actions and then run them as separate jobs when you call them. But I guess the remote workflow itself, I'm guessing, yeah, maybe it doesn't support concurrent jobs defined that way.
Okay, yeah, thanks for the clarification.
Yeah,
nice to just maybe pack into several composite actions and include them.
Yeah, I mean, so from our perspective, I'm super excited about this because we've been using the other escape hatch for a long time, which is let's see, so if I go to actions here. So GitHub has had for a while this concept of dispatched workflows. So you could, in your workflow, dispatch a payload to another repo and have it run there. And that's what we've been doing for our automated testing on Terraform. But what really sucks about it is, well, when you do dispatched events, first of all, they only trigger on master for the remote repo. And the workflows are actually executing in the remote repo. So status checks would only update commits in that repo and not the repo that was dispatching it. So that means if you want to use status checks, which is a huge part of using CI and GitHub, is you have to re-implement every single one of your status checks the hard way. So we have a Docker image here that we call every time we want to then change the GitHub status. And this is painfully not dry. If after every single step, we also have to communicate what the status is of our pipeline to the calling workflow. The other thing is, you can see how the reason why we did dispatched is because this is a massive pipeline that looks a little bit less dry because of all those status steps, but it just does a lot in this pipeline, in this workflow. So now the benefit is we can still have the power of centralizing our workflow, but the status checks would now show up in the calling repo that refers to that action. Because now when I go to any one of our Terraform repositories, like VPC, and if I look at one of the pull requests that, let's see here, if this ran tests. Yeah, so we ran the tests here. And if I go to checks, what I would expect to see when you go to checks is the output of my tests. But really, there's nothing here because it was dispatched, the events from the comments were dispatched to another repository. So we have to then navigate to the other repository to view the output of those checks. So auto test all. Actually, this one here looks like the test all didn't. 7 pending checks. Yeah, so here. So you see these here, these status checks, those we created the hard way. Those weren't automatically created by GitHub Actions, and that's because we did dispatches. And if I open this up, I think it jumps us over here. Yeah, so see, the actual run for this happened in our Cloud Posse Actions repo. And that's where we would check what the output or what the outcome of the terratest was. I hated that. So I'm really happy about Composite Actions now, allowing this entire workflow to run in the actual repo that the code is in, and then the status checks should be automatically updated that way.
Eric, I'm curious, because some of those things are already supported in Circle CI. So just wondering what made you guys choose GitHub Actions over something like
well, dude, this landscape is insane, right? There's Circle CI, there's GitLab, there's obviously Jenkins and BuildKite, and et cetera, et cetera, et cetera. There is no holy grail across all of these CI platforms or CD platforms. And the reason why I've stopped investing as a company, as Cloud Posse, in some of the commercial offerings like Circle or CodeFresh, and this is not a criticism of them in any way. It's just, it's another expense for our customers to do. They still have warts, and the warts aren't as bad as GitHub Actions. And with GitHub Actions, it's free if you deploy your own runners. And with every other SaaS solution out there, pretty much, they still charge you an arm and a leg to run your own runners using their software. And I get it, as a niche SaaS company, you have to do that. But hey, dude, GitHub Actions is pretty freaking sweet. And what I love about GitHub Actions is you drop a file in your repo, a workflow, there's no clicking around to get that configured. It just works. It automatically picks it up immediately in your pull request. versus nearly every CI solution out there requires somebody to go to your CI platform and click a bunch of buttons to register that workflow. So yeah, Circle has had the concept of orbs for a long time.
Yeah, exactly.
GitHub has that too. GitHub Actions are orbs. It's just that now there's a new kind of orb, quote unquote, for GitHub that is this concept of a composite action. It's like a composite orb. And I don't know much about Circle CI to this depth. I don't know if orbs can call other orbs that can call other orbs,
Yeah,
but that's what we're talking about. Okay. And that's what we're talking about in this situation.
Okay. Cool.
Cool. Any other questions on composite workflows or GitHub Actions?
Again, for clarification, Eric, please.
Yeah, Dennis.
Composite actions have to be public as well, yeah?
Well, actions as a primitive in the GitHub Actions ecosystem today must be public. It has nothing to do with the fact that these are composite actions, they need to be public. It's just that any actions on GitHub need to be public.
Yeah, thanks.
If they are in the same repo, can they be? Do they need to be public still, or?
So if your actions are in the same repo, no, they don't need to be public. And there is an escape hatch here. I just don't like it, so I don't recommend it. If you truly want to have private actions, there is a hack to it. You can, as your workflow, one of your steps can be to clone the other GitHub Actions repo, and then you can run the actions in that clone locally as though they were private actions. But that is the workaround. That is not the end-all be-all solution. GitHub is there is a public roadmap item to support private actions. Just it keeps on getting pushed to the next quarter and hasn't been solved yet. And to me, like, okay, so if your company as a whole operates in a mono repo, I guess it's kind of moot. Like all your actions and your workflows and everything can be in the same repo. But if you are operating in such a way where you have maybe poly mono repos, so lots of mono repos with lots of apps within them, or poly repo microservices, it gets unmanageable. So for Cloud Posse, it matters a little bit less because everything we do is already public, open source, and given away for free. But for companies that are typically more guarded about what they make public, this is a slightly tough pill to swallow.
One thing I saw in one of your repos, I think the VP's Terraform AWS VPC, you had a do not merge label. Do you have some logic behind that, or maybe part of the GitHub Actions that prevents those PRs from being merged?
That's a good question. So yes and no. So one of the things we do is, if you look at one of our repos, like the VPC module repo, and this has been rolled out rubber stamped to all of our repos, is we use Mergify. So with Mergify, automated PRs that meet certain strict criteria that were generated by like Renovate Bot and pass all of our tests can get auto merged under certain circumstances when certain files are not changed. We do not use the do not merge label right now. That would be the one place we could maybe use it would be with the Mergify rules here. The thing is that the Mergify stuff happens so fast. Like Renovate Bot opens the PR, Mergify sees it right away, runs the comments, run the tests, and within like 5 minutes, everything gets merged. And a do not merge label is usually added by us manually. So even if we had support for it here, the PR would probably get merged automatically before we even had a chance to get to it. So we use do not merge more as a convention internally to Cloud Posse about what we should merge or not merge. The other thing is the only way to programmatically enforce labels for not merging is to make it so no engineer can merge at all. And you have to delegate that responsibility to a chat bot and use chat ops to instrument the merge. So the bot is the only actor with
Oh, wow.
permission to merge.
Yeah.
Yeah.
Okay, appreciate it.
Yep. Any other questions on GitHub Actions or Composite Actions or Mergeify now? All right. So the last announcement, not Cloud Posse related, just want to bring this up. So, you know, Docker, ever since their acquisition by Mirantis, has been tightening up the hatches, you could say, trying to make Docker a actual viable business. And one of the things they did was institute rate limits for unauthenticated pulls. Many of us encountered that maybe if you didn't roll out bot users or something. Authenticated users have a higher rate limit. The next thing that they're doing now, just was announced yesterday, I believe, is companies with more than 10 million in revenue or 250 employees now are required to have a Docker license if you want to use Docker for desktop. So
now being from 22 or 2022 or 2023.
okay,
it's not from
okay.
today.
Not immediate, not immediate. Okay, so this is pending in 2022. So that I did not see that part. So thank you, Vlad, for calling that out. I appreciate it. And yeah,
It's
that's all I have.
somewhere on their official blog post.
So Docker Desktop is really for Mac and Windows users, not so much the Ubuntu or the Linux community, right?
Yeah, it is for local development largely. It is used to, you know, it also comes with Kubernetes automation within the Docker for Mac. So there's just a checkbox you can enable and exposes a Docker socket, or I mean a Kubernetes endpoint that you can use. So yeah, I think most of our customers still use Docker for Mac. It is probably the best experience now. What this means is I think there will be more investment in some of the Docker alternatives that are really getting more mature and easy to use and don't require root permissions to build images. So all in all, it's good for everyone, I think. I think it means that it'll be more mature Docker alternatives. And it means that Docker as a business becomes viable, and we have to support open source businesses. This is how they find that they have to do it. I support it. Don't worry, Cloud Posse is still free for companies with over 250 people. All right. Joking. Let's move on to Q&A. I didn't see any questions posted in office hours before, so I was just grooming or perusing the channels, picking up some questions that I saw posted throughout the week. And one of them was in the Kubernetes channel. Pierre was asking, you know, what's your strategy to size your Kubernetes node pools? And this is a good question. And I almost forgot that it's something that we have to worry about because we haven't had to deal with it now for probably almost 2 years. We have been using Spotinst, now called Spot, and it's been acquired by NetApp, but it's a third-party service that you deploy a controller in your Kubernetes cluster. You deploy special Ocean resource, which represents a node pool, and Spot, the company, will automatically provision a heterogeneous fleet of EC2 instances matching the right sized node types that you need based on your workloads that have been scheduled, basically the pods. And this has been phenomenal because like there was one time we needed to deploy a Prometheus pod with 15 gigs of RAM. Well, that meant like for like a dev cluster, maybe where we were running smaller instances, now the minimum size of a node needed to be probably, 32 gigs of RAM or something like that. What happens when you run Spot and the Spot Ocean controller is it'll automatically launch an instance of the right size to fit that pod. And it automatically handles the complex scheduling associated with the Spot marketplace, all the preemptible instances. So it has the best market intelligence based on the hundreds of thousands of nodes under management by the company across all of its customers to know when prices for Spot will fluctuate, to give you the largest runway to reschedule workloads before getting a termination request on the node. So that's one option for AWS and EKS. Someone else posted another suggestion here that like on GKE, they have the concept as well with autopilot, which will do right sizing of your nodes. So I don't know the details specifically as it relates to GKE. Any other suggestions?
A question maybe, but Eric, we can't start all the workload on the Spot instances, isn't that? It's like
I think it's a misnomer. I think it's a unqualified fear. And this, let me explain who it works for and who it does not work for. Okay, because we recently encountered this with someone, and it doesn't work for everyone. But assuming you have, let's say, at least a few pods per service, not one pod, but at least a few, right? So your pods are optimistically distributed across your fleet of nodes. And assuming you have, let's say, at least a handful of nodes, if not more. I mean, the more nodes you have, the better. If you have 2 nodes in your Kubernetes cluster, I don't consider this a fair case, right? That's like saying that you lose 1 node, you lose 50% capacity. That's unfair. If you have a cluster of 100 nodes and you lose 2 nodes, that's 2%, right? That's nothing. That shouldn't cause any disruptions. So there's lots of factors here involved. The other consideration is this, is that when you're using Spot to manage your fleet of nodes, it's a heterogeneous pool of instance types. And when market prices fluctuate for Spot instances, it's not the entire marketplace. It's different instant classes that become scarce. So what you do when you have Spot is you have a heterogeneous fleet of instance types, so that if you lose a capacity reservation for that time, then you only lose those instances. But there's 2 other things to take into account. One is that Spot has the market intelligence to know or predict when those things will happen, and preemptively launches new nodes, and so you have the additional capacity. And then there's a ultimate fallback of on demand. So if there's absolutely no availability for any of the Spot instance types as you want, it'll launch on demand instances for you. So the likelihood of a forced outage is minimal, given some assumptions. You have multiple pods per service and large enough clusters to support certain nodes going down.
Plus workload should be resilient for restarts.
Yeah, exactly. If your app doesn't tolerate downtime of individual pods or nodes, there is no miracle here, right? And the fact that you're running on-demand instances or reserved instances is only buying you additional level of assurances, but still doesn't fix the fundamental problem that exists in your app. So like one of our customers had this issue where if they have 2 pods running of the same service, they run into deadlocks. Like no infrastructure is going to solve that, right? So you fix the systemic problems in your app, then the infrastructure can do its thing.
Right.
I have a question once we're done with this topic.
Yep, for sure. Go on.
Okay. I'm just wondering if you guys have any recommendations for tracking like the infrastructure code version. So what I'm thinking is, for instance, you have an AWS tag that, of course, it's easy to create the first time that you create all your resources. You can say, you have a tag that's, the Git hash of your Git repo that has your infrastructure code. But the problem is that you want, when you later update your stack, you want the tags of only those resources that Terraform will be updating to be updated, right? So you don't want the resources that are not going to be touched to have their tags changed, right? So if I
are you talking? So you're talking about adding metadata in the form of tags to AWS resources, for example, and those tags would include perhaps the module that source and the module version.
Yeah, for example, it would be something like that. And, so that if I go to an RDS instance, I can look at the tag that's like,
I want to add this to the Cloud Posse modules. I see a nice way that we would do it for Cloud Posse through module introspection. We would do, the way we would implement it at Cloud Posse would be adding it to the null label module as a feature flag. And when you enable this feature flag, then it would look at the module version and automatically populate the tags based on looking at the module.sources. I forget exactly the JSON file, or sources.json, whatever. You can get the version of your module out of that file. So that's how we're looking at implementing it.
But wouldn't, and that wouldn't touch the resources that will not be updated? Like you don't want to force an update on all your resources just because of that.
No, but that's not fair. If it is like, so you have two ways of looking at this. And this is where it gets complicated. The resources are either tagged based on the nearest module or the top level module. So your choice is which one of those you want to implement. And both are easy, but you can't do something in between. You can't do like the middle module. But if it's the top, if you wanted to represent the module version of the top level module, it necessarily needs to change because it has changed. And if you wanted to represent the nearest module, like the local, because you can have modules calling modules calling modules. Do you want it to be the nearest module or the top level module, the farthest module?
Well, let's say that all I really want, in fact, is even maybe simpler than that. I just want the Git hash of the Git repo that contains the root module, right?
Right, but then when the root module changes, all of the other ones should change, no? Because the root changed.
Yeah, well, so what I mean is that, so let's say that, maybe I have 2 RDS instances and I do a Terraform apply and only one of the 2 is being updated. Well, I want that one to have the new hash of that commit that's causing that change, but I don't want the other RDS that isn't being changed.
The other one, but it wouldn't have it until you apply it, right? Because the metadata of the Git SHA should come from the Terraform code that's applying the tag. So you don't want an external service tagging it. You want the Terraform code actually adding the tag of the commit SHA itself.
Right.
Is that what you're thinking? And if you do that, well, it's only going to change when you run Terraform apply.
But then it seems to me like both my RDS instances will end up with that updated tag, which
no, because the tag is a property of the resource, and it only changes, the RDS resource only changes when you apply that root module. Another RDS database that happens to use the same resource won't be affected because it's technically a different instance of the resource. So yeah, I think
using the same value for the tag, it's going to change globally. How do you determine?
No, you're not supposed to be, you don't define, well, no, you don't, first of all, you're not defining the value, you're reading the value from the file system, and that value is computed during plan time and added to the tag. And because it's added to the plan, the only way you affect infrastructure is by applying that plan file, right?
Yeah, but so I think I wouldn't want to just, so let's say that I have a tag in my provider, so that I can use the default tagging, mechanism that tags all my resources that are taggable. I have a tag in there called, code version. And I read that code, I set that code version from the, the Git clone, the Git commit. That won't work because that'll automatically update the tag for all the resources, not just the ones that Terraform thinks are being changed in this latest apply. Does that make sense?
What problem are you trying to solve with this?
Well, basically, I want to be able to look at a resource in AWS and look at that tag and say, okay, this tag, this resource, say one of the RDS instances, was last updated by the infrastructure code at git hash whatever, whereas this other RDS instance was last updated for the git code, git commit hash, so and so. So that I always know which version of the Git code was the cause of this current state of an existing resource.
I think you have to think of it as in terms of applying this one value to everything, because the actual code hasn't changed for that specific resource at that point. So, the git hash single value will change everywhere. So you're right, but I think you need to accept that and think about the fact that like you're going to get a version that you're going to have to track the change back from, but it will, like, the first time, do you know what I mean? Like, if that hasn't changed, the code that you're going to be looking at is the same in both. It just doesn't have the original apply tag.
Yeah, and I guess that's the challenge, right? It's because
if you're using Spacelift as we are, it's a non-issue because the concept is you have a tracked commit, and a tracked commit is a concept with working within a monorepo where you trigger a commit to be tracked or to be run when files matching a certain pattern and a certain path change. So in this case, you have two different RDS databases. They are probably distinguished either by config files being modified or core Terraform files being modified. In either case, that would trigger a tracked commit, and that's the commit that it would be applied against. And when the Terraform plan runs, it's run against that specific commit within the repo. And through the introspection, when it reads the git commit value of the .git head file, or I forget what the file is in the Git directory, it would get the SHA of that particular commit that it's running, and that's the one that would be applied. Versus the other one would be run from a different commit at a different time and would read a different value of that commit file. So it's whatever value, when you run that plan, that's the value it's going to take. So control when you run the plans, you'll control when those SHAs change on your infrastructure.
And that's something that you guys obtain with Spacelift, you're saying? That's
what we're doing with Spacelift specifically, yeah. But I think it should be possible, like if you're using GitHub Actions with a monorepo pattern where certain paths trigger, I think it should be also feasible in that situation. Because the key is, what you're saying is you don't want to run a plan for every commit. But because if you did run a plan for every commit, it would always be changing because your head is always changing. But logically speaking, based on that pull request that RDS database didn't change because that path wasn't modified. So you want to make sure that you're planning only when paths are changing.
Yeah, no, that's fine. I would be running Terraform apply every time there's a commit, but the resources that are not in the plan should not get the new tag.
But they shouldn't be in the same state file, therefore. They should be decoupled in terms of state. So if you're doing a Terralith, that's your problem.
I mean, I may have a change that maybe adds a, I don't know, a parameter group, changes a parameter
Yeah,
parameter,
that should
and it
change the
affects only
job.
one parameter group,
Yes.
right?
No, so this is where I professionally disagree on the approach that if you are adding resources to a root module, that effectively changes the version of the entire module and every resource deployed. If you don't want that, they should be decoupled in terms of top level state and different Terraform root modules, what Cloud Posse calls components. So it's a trade-off. Yeah. So I don't see any way of handling it. Now I understand the rub here is that we're thinking about it in a single state and only modifying the resources in that state when they are changed as a result of some difference in the graph. But that's not going to happen.
I think for me it goes further than that, because it's even if I had a 5 different states that track different aspects of the infrastructure, I would want each one of these states to be able to tell me when when a particular resource was updated, from what Git hash it was updated.
It's going to require changes to Terraform core or not using.
Yeah, it might. Yeah, that's why I was curious to ask the question, because I haven't found. I mean, there are ways to do it. I've seen ways where you can, for instance, you can instrument Terraform code to ignore a tag update, right? So you can I don't know what it's called now. It's like ignore
lifecycle rules.
Yeah, exactly. Lifecycle rule, and and that works. The problem is that there's
you'll only
no
get the
way
first one then.
Yeah, well, even the first one I think is okay because it doesn't already exist. But the problem is that you have to manually do that to each of your resources, which of course is error prone, right? It's not like, that's why they came up with the concept of defining your default tags in your provider, in your AWS provider, because automatically every tag on the resource gets them. Managing, making sure that all your resources are tagged was just super error prone, right? It's the same problem here, is that there is actually a way, but it's requires a lot of discipline to make it happen.
I don't see any practical way of making it happen with turnkey Terraform.
I did something along these lines. Just briefly, I'll lay out what I did was I wanted to have, I deploy pretty much an entire environment with one state directory. We're talking about pulling out some pieces, but this is actually working just fine. So this one version, one Git hash or whatever is all I really need. So I wrote a no resource that will do a git describe, which is a nice, it gives it the last tag and how many commits since then. Or if they're in the source, if there's an actual module version of the specific module, I'll just, as you said, Eric, introspect it's .terraform modules.json, and you just use your module as the key there. And then once you get those values, I just stick them in SSM, just like as a base reference.
So Michael Jenkins posted a link, and let's treat it as a thought experiment. So like, what if one took a slightly different approach where you had like a GitHub action that ran, and it actually could modify the tag property of every taggable resource with the last known commit SHA or something. But what's ironic about that is just adding the tag itself is changing the commit. And it's a little bit of a head spin.
No, exactly. I don't think that works.
It seems like a really convoluted and complex way of doing an audit trail for Terraform.
So, I mean, I kind of.
It's a valid use case. I'm not denying that. It's a very valid use case. I'm not denying that, but it feels like you're overcomplicating and trying to fight the language a bit too much.
Yeah.
It's not going to be
starting with it's starting with a very simple question, and the answer seems to be, well, there's nothing in Terraform that allows you to
with that precision.
Yeah, exactly.
But I think therefore just change the requirements.
Yeah,
I think the requirement is when the root module changes, This is the commit SHA when the root module changed, and then that at least helps you narrow down the window. Maybe, I don't know.
Yeah.
That's
Yeah. No, that's better than nothing for sure. But what'll happen then, of course, is that every commit will end up with a plan that affects all your resources, and and 90%
For
of
that
those
state.
resources might have just a tag change, right?
Could be, but in our case, that would never happen. At least for how we think about infrastructure and how we break up our state, it would basically never happen unless something actually modified those files. That would trigger a plan, and then that would trigger the tags to change. Well, assuming that plan, yeah. So if that plan ran, if one of those files changed, and the plan ran, I guess it would rerun introspection. It would get a new SHA. It would want to modify the tags, even if it was a no-op change to infrastructure. So you're right. That's an interesting consideration I didn't think about. So my point here is like, you can change some Terraform code, like add a line of white space. That has no material effect on your resources, right? But if we were doing this introspection I'm talking about, where it would read then either the Git commit or from module sources or something, it would conceivably then get a new commit and then cause a new tag on everything, even though nothing actually changed other than white space. So I think it's a wart I would accept in order to have the traceability.
Yeah, I'm gonna have to think about that some more. It's an interesting challenge.
It's actually funny you just brought it up, because about a month ago I was working through some prototypes internally at Cloud Posse for how we would do it. Haven't pushed it forward, but yeah, it's something we're thinking about as well. So I like that you brought it up. All right, and good to see you around, Oliver. I've seen you around for a little bit.
Thanks.
Let's see what else. So one of the questions I saw come up was, in the channel, I forgot who asked it, was in the Terraform channel. What are some of the main advantages of using the Cloud Posse EKS module versus the quote normal ones? This is all a matter of perspective, right? So to us, ours is the normal one, but hey, I'll give it to you. So we, from the offset, had a very different approach to EKS and how to do it. So while the Terraform AWS Modules, which is a non-official community group of Terraformers, has one way of doing EKS, our approach from the get-go was treat node pools as disjoint, as not part of the EKS cluster itself. So basically, this allows us to make the node pool architecture custom per customer requirement versus standardized and force everyone to do it just one way. So this makes it very easy for us to mix and match combinations of spot inst versus fully managed node groups versus Fargate profile node groups in any configuration that we want, across any subnets in any way that we want, without making an enormously complex cluster, EKS cluster module, with complex maps that you got to iterate over to create it. So I feel like doing it the way we did it is a little bit easier to test. And the fact is that we actually have tests. So they aren't the end all be all. We can always improve our tests, can't we all? But at least one of the things is every change to the cluster at least confirms that our default stock settings for the module will plan, apply, and destroy cleanly, and that node groups will join the cluster. And before we had automated tests for this, oh my God, our modules never worked anytime after we received contributor requests. So I feel like this has eliminated a whole class of problems we've had running an open source ecosystem that you don't get with the Terraform AWS community modules. Now, what did I start off our call with today? Talking about our EKS Node Group module. And one of the downsides is, one of our latest changes this overhaul pull request had some breaking changes. So yes, we were unable to maintain backwards compatibility at this time, but I think that is the norm in the Terraform ecosystem today, that it's very hard to maintain multiple stable versions of modules. We're all volunteers and there's just too much work to go around. All right. Any more questions to follow up on that? Advantages, disadvantages to using Cloud Posse versus the AWS community modules? All right. Callum was asking in the ArgoCD channel if there's any opinion on how to architect ArgoCD. I feel like there's a lack of thought leadership coming out of the Argo community on exactly how to architect it. We spent a fair bit of time trying to come up with an architecture for it, and now we support ArgoCD with our customer engagements. The gist of it, from our perspective, is you have two major approaches for deploying ArgoCD. It's like, how do you partition your ArgoCD? At a minimum, you want 2 or more ArgoCD clusters, so you don't just have one ArgoCD out there. So you have to be able to have a way to test ArgoCD in a sane way, which doesn't affect your production releases. ArgoCD, as much as we learned from Jenkins over the years, ArgoCD is a recreation of Jenkins in some sad kind of ways. So it is single server, single process, and all plugins and extensions to ArgoCD require reloading ArgoCD. So that sounds a lot like Jenkins, right? Like if you got to upgrade the master, you got to restart it, you got to schedule it, you got to kill all the running jobs, and in a busy environment, that's unpalatable. So the more you have going through a single ArgoCD cluster, the more disruption you will cause to the overall organization by making changes. So that leads the conversation to maybe thinking about it in a more quote unquote HA way, or I would say partitioned way, where I think one of the downsides to having the single ArgoCD or one ArgoCD that serves multiple clusters is the orchestration of ArgoCD. So when you deploy ArgoCD, say to a shared services cluster somewhere, and then now you need that ArgoCD to talk to your other Kubernetes clusters, it works pretty well if you have a very static environment with just like 3 clusters or 5 clusters, and it just stays that way for the next 3 years. But if you are adding and removing and growing the number of clusters that you have, how are you updating your centralized ArgoCD to keep track of that? So, because it needs connectivity to each cluster. That's why I really like the last option, which is the option we prescribe, which is you deploy ArgoCD to every cluster you want continuous delivery to. That cluster is configured to look at a GitHub repo. And then it knows based on paths that you specify, when these paths change, it synchronizes. So it's decentralized in that manner. But the downside with this approach is now you don't have a single pane of glass view of your 15 ArgoCD clusters of what's going out where. You just have a glorified way of pushing commits into your Kubernetes cluster. So if you want an orchestrated, elaborate workflow between the deployments of these environments managed by Argo, you're not getting it that way. So those are my trade-offs. Any additions to that? One thing I'll add, so code, we were talking earlier about like, why not Circle CI? Why not CodeFresh? Well, here's one area where CodeFresh is a great example where, so CodeFresh has built native support for ArgoCD, and they support any number of ArgoCD clusters, and they'll present a single pane of glass view to your infrastructure with all those ArgoCD clusters and help you orchestrate a workflow of promoting software across those. So one vote for CodeFresh on that if it's interesting. All right, ArgoCD, anybody? All right. Next question is a quickie. Just came up because I saw it in one of our channels. We're getting tons of pull requests for our modules to ensure that we have support for like China region and GovCloud. And the most common reason why the modules don't work is a very simple one. It's just that we have the wrong ARN format everywhere. And honestly, anywhere you have this hard-coded, you have a problem. And the appropriate way to solve this is using the data source for the AWS partition. And I propose, I'm just curious if anybody else has implemented what I'm about to say, and that's why I wanted to bring this up. I want to have a GitHub action that enforces that the string AWS colon or ARN colon AWS is nowhere in the code. And yes, I know how we could do that as a one-line GitHub action. Yes, that's trivial. I know how to use grep. I know how to use GitHub actions. I was just wondering, is there a better one of the policy frameworks, TFSec or ConfTest, way of doing exactly this? And has anyone done it?
OPA and action ConfTest.
Yeah, ConfTest probably. So I guess with what one would have to do is, I don't know, I don't know enough about ConfTest and implementing the policies on how one would do a test to make sure that there's no quoted string that begins with ARN colon AWS. All right.
I'd
More-
like to have it run on the whenever somebody has a pull request or commit, like be a check. Hey, you're not introducing any AWS R. So
yeah,
check
it should be on the pull request itself, and but it needs to be on the code and not on the plan, right? Because the plan necessarily is going to have a hard-coded AWS colon or ARN colon AWS, but the code should not.
Good old grep.
Good old grep. Grep for the win. All right. Any other questions? Let's see here in the Zoom chat or office hours chat.
The review dog action suggester might be a thing, which if it ever finds that string, it's gonna suggest, hey, don't you wanna use
I dig it.
data that's something that's something.
Like
I've never used this one, but
yeah.
I like being helpful whenever a check fails.
No, this is cool. I think that's a good tip. I'm going to share this with RB and on that thread.
And it looks like it takes the suggestion as the output of something. Of a shell command or something. The docs are not ideal, so it could be actually using grep.
Probably. What's nice about it though is just how it creates these nicely enriched comments. I forget what you call that on GitHub, but
suggestions.
Okay.
Suggestions change, yeah.
Yeah, suggestions. Okay. Oh, so this is just like the manual suggestions, but programmatically done. Okay.
Yep.
Cool. All right. Well, any other? Let me see the Slack here. Office hours.
Just a quick question: is terratest still the best way to test?
As far as I can tell, this came up briefly last week when Anton was on the call. I think from my vantage, terratest is the only mature testing solution used across lots of organizations that's mature. There's Test Kitchen, which I used to see when we first came to Terraform, but I barely see that anywhere anymore. And I'm not a big fan of installing the Ruby kitchen sink to run the automated tests. HashiCorp has a RFC, so to say, for how to do testing in pure Terraform. There's provisional support for it in Terraform 1.x. There's a feature flag or something you enable to use it. Here's the deal though. There is no level of built-in Terraform testing that will be adequate to do appropriate testing for infrastructure, I think, the kind of testing we want to do. So how do you instantiate something with 250 different combinations of values in a matrix and apply?
Oh, yeah.
Or how do you actually do a functional test that once your EKS cluster is online, that you can actually deploy a pod and that pod gets scheduled, right? Those things get really hard if you're just doing pure HCL tests. So what those tests were gonna do is kind of like, hey, if you implement a testing in the HCL, like, okay, you provision a EKS cluster and the output has a value that looks like this, and you expected it to be enabled, and lo and behold, it's enabled. Okay, cool. But you're not going to get the more advanced things. Like in our EKS cluster terratest, we actually have to wait for the nodes to join, and then we test running a command against the cluster once those nodes have joined.
Mhm.
Now, most of our tests aren't that advanced, but that was one example where we just had so much instability with the EKS cluster module, we had to have more mature tests on basic functionality.
Cool.
It does, I think, it opens up a bigger question though. It's like, how to do tests in a open source community? And do we expect contributors to be Go developers and to be able to update our tests? And for the most part, we don't. If they break our tests, we expect them to fix it. But if they are adding functionality, we're not really saying, go add the test, because it's kind of like saying, yeah, screw you, don't, thanks for your contribution, but we're never going to accept it. And I don't want that. I want to feel like everybody's contribution is valued. So we do accept most pull requests, even if they don't update our tests or anything.
Stuff.
All right, everyone. Well, we are out of time for today. Thank you so much for participating. I did want to just drop a few other slides here. If you haven't yet subscribed to our YouTube channel, head over to youtube.com/c/cloudposse and subscribe. Those subscribes help us out a great bit in the ecosystem, basically giving us more views and prioritization of our content. The other things to check out is to register, obviously, for next week's office hours. We send out an invite before every event reminding you of office hours. Go to cloudposse.com/office hours to register for those. If you are looking to catch up on past episodes, head over to podcast.cloudposse.com. You can always listen to it from however you listen to podcasts. Also, I love connecting with everyone in the community. My LinkedIn is here, linkedin.com/in/Osterman. Feel free to reach out to me on there. And Cloud Posse, we're always looking to hire contractors. So if you are looking for your next gig, please reach out, and we look forward to talking with you soon. Take care, everyone.